Since so many of us did poorly on this quiz, I'm deciding to explain every question on this quiz. It's for you, for a tool, all right? So on the first 5 questions, they ask us to use the following piecewise functions, g of x and r of x, to answer 1 through 5. So g of 0, saying that we're going to use the g function, and the 0, this is just the function notation saying that you're going to place 0 where x is at, but obviously not here. This is just the name of it. You're going to plug in 0 for x either on this top piece or this bottom piece. And in order for you to determine which piece you're using, you have to think about, is 0 less than 2 or is 0 greater than or equal to 2? Well, obviously 0 is less than 2, so you're going to be using this one, okay? So let's actually plug in by rewriting 2x, but instead of 2x, I write 2 times parenthesis, and we do have the x value of 0 that we're substituting in there, which means that 2 times 0 is 0. So your final answer for number 1 is 0. Moving on to number 2, r of negative 4. Here's r, and we need to plug in negative 4 somewhere. Well, if we say negative 4 is greater than negative 2, that'd be incorrect because negative 4 is further on the left side on the number line, so it's more negative, which means it's smaller. If you go up here, negative 4 is not less than negative 4. Negative 4 is equal to negative 4. So right here is the only place that it would fit. Negative 4 is greater than or equal to. The or equal to allows it to be in here because negative 4 is equal to negative 4. So we're going to plug in negative 4 right into this x. So I'm going to rewrite this negative 1/2 x. In other words, I'm going to write it as negative 1/2 parentheses. And we're actually plugging in the x value of negative 4 right in there. And of course, when you're multiplying a fraction times a number, simply put the number over 1, multiply the top with the top and the bottom with the bottom, and then reduce or divide. So negative 1 times negative 4 is positive 4, and 2 times 1 is 2. And 4 divided by 2 is 2. Moving on, g of 5. We're going to plug in 5 into the g function, but we need to know where to plug it in. Is 5 less than 2? No, it's not. Is 5 greater than or equal to 2? No, it's definitely not equal, but it is greater than. So 5 is greater than 2. So let's plug it in right here. So it's going to be 5 minus 1. If I actually write that out, 5 minus 1. The only reason I put parentheses is to remind you to plug in with parentheses, but you don't need those parentheses because 5 take away 1 is simply 4. That's your answer for number 3. Number 1 was 0, number 2 is 2, number 3 is 4. Let's go for number 4. We're going to plug in negative 3 into the r function, which is right here, but we need to know where to plug it in. Negative 3 is not less than negative 4. Negative 3 is between negative 4 and negative 2 on the number line, so it satisfies it. We need to use this one. Negative 3 is definitely not greater than negative 2, so it works right here, so we need to use this one. Let's rewrite it, negative 1/2 times parentheses instead of x. So we're going to go negative 1/2 times parentheses instead of x, and we're going to plug in the x value of negative 3. Now, if you do this with the calculator, you're going to get positive 3/2. So I would have accepted positive 3/2. I would have accepted 1 and 1/2 if you wrote it as a mixed fraction. I would have even accepted a decimal 1.5. Either of these 3 answers are great. Moving on, number 5, g of 2. So we're going to plug in 2 into the g function, which is over here. But the question is, do I plug it up here or down here? Well, is 2 less than 2? No, it's not. Is 2 greater than or equal to 2? It's equal to. So I'm going to be using this bottom one. So plug in 2 right here, and that will read 2 take away 1. So your final answer is just 1. So we have the 5 answers so far. And on your answer spot, you should have written these answers: 0, 2, 4, 3/2, or you could have also written 1.5, or you could have written it as a mixed fraction, 1 and 1/2. Either of those 3 would have been acceptable. And number 5, the answer is 1. Now, the next portion is worth 2 points, questions 6 and 7. And all we're doing is graphing the above function g of x. So we're going to take these 2 pieces and graph them right here, and that'll be worth 2 points. So we need to graph y equals 2x, and if it helps you, go ahead and write that down, y equals 2x. And where does that cross the y-axis? It crosses at 0. And from that point, you go up 2 over 1. And you could continue to go up 2 over 1. And you could go backwards with that pattern down 2 over 1 the opposite direction, right? But we need to show the piece of the line that our condition tells us to. So it obviously says if x is less than 2. So you have to go to your x number line, okay? And I'm doing this before even drawing the line, but I go to the x number line and I go to the value of 2, and I want to show the values that are less than 2. So as you can see, I blocked out, it's like if you put a piece of paper right above the number 2. So my line's going to start here and go in this direction. I don't want to show this part of it, okay? So if I would have drawn it all the way through, then I would want to erase this part and just show this part, okay? So the question is this dot going to be an open dot or a solid dot based on this? Well, if there's no solid line underneath it, it's not going to be a solid dot. It's going to be an open dot. So let's do that. Let's erase, put an open dot right there. And it is going in this direction. So you could extend it as far as you want, but you have to put an arrow going down to the bottom and to the left. All right, let's do the other piece. Let me get this out of the way. The other piece reads y equals x minus 1. If you want a different color, go for it. Y equals x minus 1. So that one crosses the y-axis at -1. And from that point, you go up 1 over 1 and up 1 over 1. And you could use the pattern backwards, but here's my line, right? The question is, what piece of this line am I going to show? It says if x is greater than or equal to 2. So I want to go to the x value of 2 on my number line and cover up everything else on the left side. Just show the right side because it says greater than or equal to. So greater than or equal to 2 would be right here. So I need to show this part of it, okay? So I need to erase this part of it. So let me actually go back and extend this out even further. And I only want to show the values that are greater than 2 on the x. So I don't want to show the value that's at x equals 1, and I don't want to show, I can't erase it right now, so I'm going to just white it out. I can't show the x equals 1 or the x equals 0. I need to erase those. And it begins at x equals 2, and it is a solid dot right here. And you only want to show this side of it. Put an arrow. So everybody should have had this graph in order to get your 2 points right here on number 6 and 7. Okay. Let's move on to number 8 and 9. 8 and 9, that's a 3-piece piecewise function. So we're going to begin with the top one. Top one reads y equals 3. So let's think about this. Y equals 3. That's going to be a flat line crossing the y-axis at the value of 3. Keep in mind that we're only going to be looking at a piece of it. So here's my line, my flat horizontal line crossing the y-axis at 3. But I only want to show a portion of this line. And what's the portion? The portion is if x is less than -4. So I know it's going to be an open dot because it does not have a solid line underneath it. It's going to be less than -4. So go to your x-axis. Use your x-axis. Go to -4. And you want to show the less than portion of it. So that's to the left, not to the right. So what we're doing in a sense is covering up all of this piece right here. And we're just showing the -4 and this way. So we're just showing this piece of it. We don't want to show any of the other piece, so I'm going to erase the rest. Okay, let's erase the rest. There we go. And it's going to be an open dot like we said. So here's my open dot, and it is going that way. Everybody should have done that little piece for their first part of this piecewise function. Now let's move on to the next piece. And the next piece reads y equals -1/2 x. Just to make it a little easier for you to understand, let me write it down. Y equals -1/2 x, which means plus 0. Because there is no b value, which means it crosses the y-axis right at 0. Okay, now my slope is negative 1 over 2. So I want to go down 1 over 2 and down 1 over 2, and I want to go backwards over 2 up 1 over 2, over 2 up 1 over 2 up 1. And I could draw my line. I will this time. But we only want to show a piece of this line, and the piece is between negative 4 and negative 2. So between negative 4 and negative 2, you guys see this portion between my two red dots? That's the only piece that I want to show. So I would have to erase everything else. And at negative 4, this dot right here, it's a solid dot. And at negative 2, that's an open dot. So it should be an open dot here, solid dot here. Again, open dot here, solid dot here. So let me modify my graph and put that open dot right here and my solid dot over here. So that's the correct second portion of this piecewise function. Now let's move on to the third piece of this piecewise function. Y equals 3/2 x minus 2. Let's write that down. Y equals 3/2 x minus 2. So this crosses the y-axis at negative 2. And from this point, you're going to go up 3. You're going to go up 1, 2, 3, and over 2, and put a dot right there. And of course, you could continue going up 1, 2, 3, over 2, and put a dot right there. You could even go backwards. Let me go backwards with this pattern, down 3 over 2, and put a dot right here. Okay, now your line is going to go right through all of these, but you're going to have to erase a certain portion of it. Okay. The question is, what portion am I going to erase? Depends on your restriction up here. It says if x is greater than negative 2. So where's negative 2 on the x-axis? It's right here. And you want to show the greater than piece of it. Greater than's to the right. So you don't want to show anything on the left side of this location. You want to show everything on the right side of this location. So if I were to cover up the left side of negative 2 on the x, that would mean I should not continue this way and put an arrow right here. I need to erase this. This is where it begins, and it does go in this direction. I want to show the right side of negative 2 because it says x is greater than negative 2. So show the right side of negative 2, which is this. Now the question is this going to be an open dot where it begins or a solid dot? Well, you got to look up here at your restriction, at your domain. It says x is greater than negative 2. So there is no solid line underneath it, so it's not going to be a solid dot. So I'm going to erase the arrow, erase this dot, put an open dot, and that's how it's going to look. So let's do that. Erase the arrow, erase the dot, put the open dot. And that's my correct piecewise function. A lot of us struggled doing these piecewise functions, especially for some reason this piece right here. For some reason people would write it down here and in the opposite direction. Okay. So I hope you have all those three pieces graphed correctly. I hope if you don't, now you do know how to do it. And now let's move on to stating the domain and the range of each of these. So number 10 says state the domain of the above g of x function. Here's g of x. So domain are your x values. Does either of these pieces go to the left and to the right forever? And the answer is yes. The left one, the red one goes down but to the left, down but to the left. So it's going to keep going to the left forever. And the blue one keeps going to the right forever, and there is no missing pieces, right? What I mean by missing pieces, this is an open dot, this is a solid dot, so there are no missing pieces. So I could safely say for my domain on number 10, the domain of g of x, you should write this, domain x equals all real numbers. Some people put all real numbers and they didn't put x equals. I can't give you full credit for that because I don't know if you're talking about the x values or the y values. And with domain, it specifically has to be x values. So the domain is x equals all real numbers. Moving on to the range of g of x. The range, does it go up forever and does it go down forever? That's obvious. The blue goes up, the red goes down forever. There are no gaps in between the up and down going forever. So this is the range would be y equals all real numbers. So that was a pretty easy 2 points if you graphed it correctly, and a lot of us didn't, so that was a problem. Now let's state the domain and the range for the r of x function. the r of x function, well, does it go, the domain or the x values, does it go to the left forever? Yes, obviously the red goes to the left forever. Does it go to the right forever? Yes, the green goes to the right forever. Now here's the tricky part where a lot of people messed up. Is there any gaps? Is there any missing values that x cannot be? Now what do I mean by that, guys? If I say, like, what's your output when I give you the input 2? Well, if you go to the graph and you go to the input 2, it'll give you the output 1. If you go to the graph and put the input 0, it'll give you the output -2. If you go to the graph and put the input -4, it'll give you the output +3. It's like they're just coordinates on the graph. Remember, all coordinates are input and output values, which means that the x value of the coordinate that you're looking at, that's your input, and it gives you the output, which is the y value of that coordinate that you're looking at. So if I want to look at this coordinate tells me that if I plug in the -4 for x, it'll give me a 2 for y. So when we're stating the domain, we need to find out if there's any missing values. And the missing value is -2 for x. It cannot be, x cannot be -2 because there is no y value. Look, there's a hole right there and there's a hole right here. That didn't happen over here. We had a hole, but it was covered with this dot over here. So there's an actual missing value, so x cannot be -2. All right, so let's state this the way it's supposed to be stated. The domain, you could say x equals all real numbers, but x cannot be -2. You have to throw this in, that if you go to the -2 on the x, you're going to have a missing value for y. All right, and that's the only place this whole graph where it happens. So you have to state this piece that x cannot be -2. Why? Because it's undefined at y. There's no y value for it. There's a hole right there, so it's not continuous. Let's move on to number 13. State the range of this piecewise function. The range are your y values. Does it go up forever? Absolutely. The green arrow covers it all, goes up forever. Does it go down forever? No, it doesn't. There is no arrow pointing down. So obviously this is your lowest y value, and you can't even include it because it's an open dot. So we would say for the range on this one, range is going to be the y values that are above the -5 value, because this is the -5 on y. It can't even be or equal to because it's an open dot, so it's above -5. Moving on to the more fun stuff right here. I give you a piecewise function graph, and you're supposed to come up with the actual piecewise function h of x that will produce this piecewise function graph. So what I recommend doing is with a pencil, lightly extend your line, okay? So, and here's another detail, guys. Another mistake I saw was that students, you guys started with this one. I mean, yeah, this is probably the easiest one to graph, but how do we look at graphs really? We need to look at them from left to right. So that would imply that this should be your first line that you talk about on your piecewise function. So this is the first one, and then from here it goes down to this one. So this is the second line you should be looking at. And then this one should be your last line that you're talking about on your piecewise function when you organize it. So the first one should be this one, the second one should be this one, and the last one should be this flat line. Okay, so let's start with this one. What line is this? I would take your pencil and I would extend it according to the slope that you see. So there's a dot here, it crosses through a nice clean point, nice clean coordinate, -3, -1, and it goes up to 0 here. So what is that slope? It's up 1 over 1, 2, 3. So the slope is positive 1/3. After all, it is going up from left to right, up and over. So positive, the rise is positive, the run's positive. So the slope is 1/3. And what's the b value? The b value is 0. It crosses the y-axis at 0. So this equation right here, and it's okay to write on this, you would write y equals positive 1/3 x. You could put the plus 0, but that's totally unnecessary. But I hope we see that if I were to have extended this line of up 1 over 1, 2, 3, I'd end up with the line over here, right? They're just not showing us that piece. we're going to have a restriction on this line, okay? So let me erase this piece. What's the restriction? Obviously, they want us to show the left side, not the right side of it. They don't show any of this part up here. They only show the left side. So they're showing the left side, which means that you're going to have x being less than or equal to, because it's a solid dot, less than or equal to a certain value. And that value on x is 0, right? Here's 1, here's 2, here's -1, here's -2. It's 0. It starts here and it goes in this direction. So let's begin by doing the first part of this piecewise function. Put some giant brackets like this. And the first part is going to be y equals what? Y equals 1/3 x plus 0. But I'm just going to write it as 1/3 x. So we're going to put 1/3 x right there. Now, what's the condition? If x is what? Greater than 0 or less than 0? X is less than or equal to, because it's a solid dot. So less than or equal to 0. So if x is less than or equal to 0. Let's move on to the next line, which we look at from left to right. So this one is a line. You could extend it if you want, extend it in both directions. But the bottom line is you need to be able to count the slope and find out what the y-intercept is for you to be able to write this equation in slope-intercept form. So let's get a little closer to this. What is the slope? Well, from one point to another, you go up 1, 2, over 1. Up 1, 2, over 1. So obviously the slope is up 2 over 1, which means that my equation begins y equals up 2 over 1 with an x. Now, where would it cross my y-axis? It obviously crosses my y-axis at this location, but it's an open dot, all right? Keep that in mind. So we'll do that. We'll keep that in mind when we do the inequality of the restriction of this line. But it does look like it would cross at -6. So we have the equation y equals 2 over 1x minus 6. A lot of us forgot that -6, the b value of your y equals mx plus b equation. And if you wanted to write it nicer, cleaner, it would be y equals just 2x minus 6. You don't need the 2 over 1. Anyhow, this line normally would go this way forever and up this way forever, but obviously you're only looking at it in a piece of it. And what is the piece? It's between your x value of 0 and between your x value of 2. So when you have a piece of a line that's between one location and another, between 0 and 2, you're going to have to write it as a compound inequality. Let's first begin by writing the actual equation into our piecewise function over here. So the actual equation is y equals 2x minus 6. Here it is, y equals, let's write 2x minus 6 right here. 2x minus 6. Okay, now let's go for our condition, which is what piece of this long line are we looking at? We're looking at it from the x value of 0 to the x value of 2. So between 0 and 2 is where this line is at with regards to x's, between 0 and 2, and both open dots. So we're going to put the if, like we always do, and we're going to put the line, the x, between 0 and 2. Okay, and since they're not solid dots, you're only going to put less than symbols, not less than or equal to. So that's the second piece. Now let's move on to our third piece, which is actually the easiest. This one would normally be a totally flat line crossing the y-axis at 1, not at 2, right? It goes 1, 2, goes 1, 2, so it crosses it at 1. I should have said -1, -2. Yeah, but it crosses at 1. So if I were to look at this line right here and extend it this way, what would that line actually be? It would be y equals 1. It's a totally flat line. There is no slope. There is no x. It's just a line crossing through the y-axis at the y value of 1. So we're going to write this equation right here as my third piece. How would I write it? Y equals 1. Y equals, what am I going to put here? A 1. Now we need a restriction because y equals 1, it's the whole thing. And obviously they're only showing us from here to the right, right? From the value of 2 and greater than. So I need to represent that piece of it by saying if my x value is greater than or equal to 2. Now why or equal to? Because it's a solid dot. Okay, so you could write the actual equations on this on each line. That way it'll be easier for you to understand. And now for the easy part, Number 16, state h of 1. And of course, we're talking about the above h of x piecewise function. And if it's graphed for you, you don't actually have to plug in 1 and do all the math. I mean, you could do that. Like, check it out. You could say, okay, I want to plug in 1. Where do I plug in 1? Do I plug it in up here, right here in the middle, or in the bottom one, which would imply that my answer is 1? Well, where would 1 fit into x? Well, is 1 less than or equal to 0? No. Is 1 greater than or equal to 2? No. Is 1 between 0 and 2? Yeah, it is. 1 is between 0 and 2. So you would technically take the 1 and plug it right into the middle one, because that's the condition that it satisfies. And you would say 2 times 1 is 2, and 2 take away 6 is -4. But of course, that would imply that you did all of this correctly, perfectly. Because if you didn't do it right, then you're not going to be able to get this right answer. But here's the easier way of doing it. If it's graphed for you, then you know that this is correct. I mean, it's graphed. And what this is saying is, what would your output be if your input's 1? And if we're talking about inputs and outputs, we're really talking about coordinates on an XY plane. So what would my output be for my input 1? Well, that's like saying, what coordinate has the x value of 1? And if you go over here, go to the x value of 1. Is there any coordinate up here? No. Is there any coordinate down here that has the x value of 1? Yeah, here it is, right here. As a matter of fact, I'm going to put a red dot right there. And what is the location of that red dot? That's 1, -4. Now, what does that actually mean? It means that if my input is 1, my output is going to be -4. And that's what this is asking you. If your input's 1, what's your output going to be? It's going to be -4. There it is. So you didn't have to plug it in and do the math. You could just look at the graph and see where the coordinate is that has that x value, and then get the y value from that coordinate, and you're done. Number 17, state h of 0, which means plug in 0 for h. So instead of plugging in over here, let's just look at the graph. This is saying, if your input's 0, what's your output going to be? If your x value is 0, what's your y value going to be? So let's go to the x value of 0. So here's the x value of 0. Is there any coordinate? That's an open dot. No, oh, wait a minute. This is a solid dot right here. So this dot is part of my piecewise function. That's a solution. This dot right here is the location 0, 0. So if your x value is 0, what's your y value? It's also 0. So you got 2 answers without having to do any of this, right? Now the last one is a little more tricky. Why? Because it says the input -9, what's your output? If your x value is -9, what's your y value? So obviously it's not on the graph. Here's -2, -3, -4, 5, 6, and at -6 you're at -2. And then you have to go to -9, which would be down here. And if you were to actually extend this, this would be the level of the y level of -3. If you were to extend it all the way out here. So this coordinate would be -9, -3. But obviously you can't really see that because it's not on your graph. So you have to resort to doing algebra right here. Plugging in -9 into the function. And is -9 less than or equal to 0? Yeah, and any negative number is less than 0. So you'd plug it into this one. So doing the math, it would be 1/3 times -9. This is your input. Plug in -9. Put the -9 over 1. And then simply multiply, top with the top, bottom with the bottom. You'd get -9 over 3, which gives you -3 as an output. And visually, that makes sense, because if you go out to -9 and you go down to that line, it'll be at the y value of -3. So the output would be -3. The coordinate would be -9, -3, and it would be right here, right on the line. Okay, so I hope this explanation of this quiz helps. I'll see you soon.